In this lesson we're going to be looking at factorising by completing the square. This may already be a technique that you're aware of. It's specifically some of this technique should be revision to you. Other bits of it will be new work related to complex numbers. So before we go too much further into some of the tricky ones, let's just have a look at a reasonably simple example to begin with. The question says factorise z squared plus 4z plus 13. First of all, we notice it's a quadratic. So, you know, your immediate thought when you're factorising quadratics should be, can you do it by cross method? So you know your factors of z as z squared as z and z. The factors of 13, well, there's only, as far as whole numbers are concerned, there's only those two factors of 13, and clearly you're not going to get a 4z out of that. So this method of factorising doesn't seem like it's going to work on this occasion. So we can cross that out, and we need to find a different, more suitable method. And that method is going to be what we call completing the square. Now you'll see what I mean by completing the square in a moment. Alright, what we want to do, or the method of completing the square is, first of all, you need to make sure that the coefficient of the z squared term is 1. Clearly it is at the moment. In the next example I'll do one where it's not, and we'll see how to do that. So the coefficient is 1, that's good. So we write down our first two terms, and we say to ourselves, okay, we take this coefficient of z here, it's a positive 4. We halve it, it would give us positive 2. Then we square it, would give us positive 4. But we can't just go adding 4 into this problem. Let's get rid of that 4. So far that 4 take away 4, depending on how we group it, but as it is there, it cancels itself out and we're left with what we had at the top, provided we write the plus 13 in. So the 4 take away 4 gives you nothing, and we've got, mathematically this is identical in value to that. But the trick here is that we now group those together and we group these ones together. So what we get here is z squared plus 4z, I'm just going to write it again clearly, plus 4, and then out here we're going to have negative 4 plus 13 is positive 9. Now this bit, z squared plus 4z plus 4, is actually what we call a perfect square. That's what completing the square is all about. It's making a perfect square out of it. This z squared plus 4z plus 4 we know is z plus 2 all squared. If you can't quite follow that, there's a couple of ways we could show that. We could actually try and factorise. All I'm looking at is this bit, what we call the perfect square. Factors of z squared are z and z. Factors of positive 4 are 2 and 2. Positive 2. Check your middle term. 2z plus 2z gives 4z. Yes, these are correct. So our factors are z plus 2 and z plus 2. Both of them the same, which is really z plus 2 all squared plus 9. Another way you can double check, if you were to expand the perfect square, you should come back to this. Remember our rules for expanding perfect squares. First term squared, yep. Twice the product of the two terms. So the product of the two terms is 2z. Twice that, or double that, would be 4z. Yep, that's what we got. Second term squared, certainly gives us that. Alright, so this is the process of completing the square. Now what do we do? Because the question said to factorize. Factorize means I need to end up with something times something else. This expression, this polynomial, must be equal to something times something else. If it wasn't for this 9 here, we'd be finished, because I'd have 2 brackets, or squared at least. But I want one bracket times another bracket. So this is the trick now. This is where the complex numbers come in. Z plus 2 all squared, take away 9i squared. Now remember, in complex numbers, I squared is -1. So -1 times -9 really would give us +9. Why on earth would we do that? Because now we've effectively got a squared minus b squared. We've really got z plus 2 squared minus 3i squared. Which is really a squared minus b squared. Now what does a squared minus b squared equal in your factorising rules? A minus b, a plus b. I've got a squared minus b squared, so that's really a minus b, brackets, a, z plus 2, plus b. Now we could have little brackets around there if you wanted to. So a squared is z plus 2 squared, so a itself must be just z plus 2, minus b, a plus b. It doesn't matter in this case whether those z plus 2's are in brackets. But we have now factorised this polynomial. This polynomial is equal to that factor multiplied by that factor. 2 brackets multiplied together are the factors of this particular polynomial. Okay, let's try a slightly harder one. We'll go to a new page. Okay, let's try this one. Factorize 4z squared actually I'll do a different one first. Z squared minus 3z plus 5. Z squared minus 3z plus 5. Okay. Completing the square says make sure your coefficient is 1. Yes, it is, especially now that I crossed that out. So z squared minus 3z. Always write down those first 2 terms. Then we take this coefficient, we halve it. When we halve it, don't try and say 1.5, just say 3 over 2. Whenever we halve something, we divide it by 2, so just say negative 3 over 2. Then we square it and add it on. So we've got 3 over 2, negative 3 over 2 squared. So I halved it, and I got negative 3 over 2. I then square it. So I've got negative 3 over 2 squared. I've put all that, instead of just going to the answer, I've put the actual working in. I can't just go adding that to the problem. I better get rid of it. But then I can't forget that I had the plus 5. Now what does that give me? Z squared minus 3z plus 9 over 4. And when you get better at these, when you get more practiced at them, I would go straight to the 9 over 4, because when I'd come to the negative 3, we halve it, we get 3 over 2, we square it, we get 9 over 4. Okay, that's the process I'd take. Subtract 9 over 4 plus the 5. Now it relies on how we group it. I'm going to go z squared minus 3z plus 9 over 4. We're going to group them together, and we're going to group these together. Now negative 9 over 4 plus 5, if we want that over 4, that's going to be 20 over 4, because it's 5 over 1. Get a common denominator. I still want to group these things together, so I'm just going to leave this as it is for now. So just one step at a time. So that's going to give me plus 11 over 4. Now this bit, I could have done it earlier up, but this bit is going to become a perfect square. It always will, because you've got your z squared term, your z term, and your constant term here you got by halving and squaring this, which is what always gives you your constant term. So when we factorize this, it's going to be z, and the other term that comes in here is whatever we got when we halved this coefficient. So when we halved that coefficient, we got negative 3 over 2. So that's what goes in the bracket there. Let's just check that what we've written here by inspection is actually correct. If we expand it, we should get back to that. So first term squared, yep, z squared. Twice the product of the two terms. If I multiply these, I'll get 3z divided by 2. But then I've got to twice that product, double that product. So 3z over 2 times 2, well the 2's would cancel and you'd be left with negative 3z, which is our middle term. Second term squared, negative 3 over 2 squared gives us 9 over 4. So this is in fact the factorized version of that, or the perfect square of that part of the polynomial, plus 11 over 4. Now we haven't fully factorized yet because we've still got this plus business on the end. Factorizing means it all has to have one term multiplied by the other. So I'm going to leave this as z minus 3 over 2 squared, and magically I can convert this to a negative 11 over 4 and put an I squared in, because I squared is negative 1, so that the negative times the I squared would go back to a positive. You've now got an A squared minus a B squared scenario. So we know that is A minus B, A plus B. So if this is A squared, A would be z minus 3 over 2 minus B. Now be careful here, B will be the square root of all of this, so that would be minus square root 11 over 2, because I can take the square root of 4 and just write 2, and I can take the square root of I squared and just write I. So A minus B, then A, remember don't change that negative sign there, that's just part of the A, plus B, square root 11 over 2 I. And there we have fully factorized. We've fully factorized the original polynomial. Alright, in the next video I'll just do one harder example of completing the square.